Well, good morning. It's Mr. Nelson again. Today we're going to be studying standing waves. It's a little different than the wave patterns we studied last week. And you'll notice in the document I'm sharing with you, it'll define a standing wave as a wave confined in space. And what that means is the wave energy is bouncing back and forth, and it creates this standing wave-like pattern that appears to be standing still. You can't tell what direction it's moving. A vibrating strings on a guitar, any string instrument, uses standing wave patterns. Microwaves in your microwave oven create standing wave patterns. And when the wave is oscillating back and forth, it'll create a pattern that we refer to as harmonics. And if you look at this little image on the right, the first harmonic looks like one big wave. The second harmonic has two little bumps in the wave, two what we call antinodes and one node. The third harmonic has three antinodes and two nodes in between. The nodes are the points of minimal or zero amplitude in the middle, and the antinodes are midway between consecutive nodes, those points where the wave is expanding to maximum amplitude. And as you study standing waves, a wavelength, remember, a standing wave, if you imagine this wave traveling from left to right, it would then reflect back from right to left, and it would interfere with itself, and it would create this pattern. So you have to isolate two consecutive nodes to get one full wavelength. And so this image here at the bottom is the third harmonic, which has 1.5 wavelengths. You're going to be studying these patterns. You're going to be looking at problems. And before we start it, I just want to open up the simulator that you've seen before to play around with some of these standing wave patterns. Now, if I send a wave from left to right, you can see how it travels. And then you could measure its speed. But once it starts interfering with itself, you can't tell, which direction it's moving. Let me restart that. If it's just traveling left to right, you can see a pulse oscillating and shaking, traveling at some speed. But again, once it reflects back, and it creates this vibrating pattern that oscillates back and forth, you can see points in between here and here that are not moving much. These are nodes, 1, 2, 3. It looks like there are 3 points of minimal amplitude, or nodes, 3 nodes. And then the points in between there have amplitudes that are expanding, they're amplifying. And those are antinodes. We have 1, 2, 3, 4 antinodes. So this image that I've created, I'm creating a wave with a small amplitude at first, and as it gets sent and oscillates back and forth, this is creating the fourth harmonic. It has 4 antinodes and 3 nodes in between. Study those patterns in the handouts provided in the document, and then check the problems that provided with the answer key to see if you're correct. Good luck.